Now it's time to go back over everything we've looked at in this unit about polynomials. So to begin with, we started with adding, subtracting, and multiplying, our basic polynomial operations. So remember, when you add, I don't need the parentheses. All I'm going to do is combine my like terms. So if I start from the beginning, I've got a 2x squared, which doesn't have anything else to go with it, so I'm just going to bring the 2x squared into my answer. I have a negative 3x cubed and a positive 3x cubed, which actually end up canceling. Then I have a 7x, which doesn't have anything, as well as a minus 1. All right, make sure that your exponents are in descending order, so this is in standard form, and so that is my answer. I don't have to do anything else to it. Subtraction is a little different because I have to look at that negative 1 that's in front of the second parentheses and distribute it. So I'm going to rewrite this one as 2x squared minus 3x cubed, and then minus 3x cubed minus 7x plus 1. All my signs in the second parentheses changed. All right, then I'm going to look for my like terms. So I've got negative or positive 2x squared by itself again. Then I have negative 3x cubed and negative 3x cubed to get negative 6x cubed. And I have the negative 7x by itself and the positive 1 by itself. Now this is almost complete, except that I need it to be in standard form, so this x cubed needs to come first. So I'm just going to rewrite it with the negative 6x cubed out front, a positive 2x squared, a negative 7x, and my positive 1. So 3, 2, 1, 0. And for the last one, we have multiplying. So we have two ways of multiplying. One is like the FOIL method, and one is a box method. So we'll do both, just so we review both, but you don't have to be able to do both. So we'll start with the FOIL method. So I'm going to take everything in my first parentheses and multiply it by everything in the second. So 2x squared times 3x cubed gives us 6x to the fifth. 2x squared times 7x is 14x cubed. And 2x squared times negative 1 is negative 2x squared. Same thing with the 3x cubed. So times 3x cubed gives us negative 9x to the 6th. Times 7x gives us negative 21x to the 4th. And then times negative 1 gives us a positive 3x cubed. Right now I'm going to combine any like terms and write it in standard form. So I'm going to start with my biggest exponent, which is this 9x to the 6th. It's a negative 9x to the 6th. Nothing goes with it, so I'm just going to bring it down. Then I go to the 5. I don't have any other 5, so 6x to the 5th. All right, then I go to the 4. I don't have anything else to the 4, so bring down the negative 21x to the 4th. All right, then I do have 2x cubes. I got a 14 and a 3 to give me 17x cubed. And then I've got a negative 2x squared by itself, so we'll bring that one down. So then this long polynomial becomes my answer. Right, the second way of multiplying is the box method. So in this case, I have a binomial times a trinomial, so I need a 2 by 3 box. All right, so for this one, I have 2 going down, so that's where I put my binomial. And then my trinomial is going to go across the top. All right, so 2x squared times 3x cubed is 6x to the 5th. Negative 3x cubed times 3x cubed is negative 9x to the 6th. 2x squared times 7x is 14x squared, cubed, sorry. 2x squared times negative 1 is negative 2x squared. Negative 3x cubed times 7x is negative 21x to the 4th. And then negative 3x cubed times negative 1 is positive 3x cubed. If you have any like terms, if you only have one set here, they're going to be diagonal. So in this case, they're here. And then I'm going to bring everything out in standard form and get the answer we just had with the FOIL method. Right, then we went into division, and we had two different ways of dividing. One is long division and one is synthetic division. So to start with long division, you take whatever you're dividing by and put it on the outside of your division bar. And then everything else goes under your division bar, but you have to remember to look for those placeholders. Okay, so in this case, I have x to the 4th, x squared, x to the 1st, and then no x. So I'm missing that x cubed, so I'm going to need to put a 0x cubed in there. So I have 4x to the 4th plus 0x cubed minus 6x squared plus 2x minus 5. And remember, whenever we're doing long division, we always start with whatever that first term is that we're dividing by. All right, so in this case, I'm working with x. So x, got my plus here, x times something gives me 4x to the 4th. And that something is 4x cubed. So now I'm going to take 4x cubed and multiply it by x plus 3. And that's going to give me my first line down here. So 4x cubed times x is 4x to the 4th. And then 4x cubed times 3 is 12x cubed. And then I subtract. The first one should always cancel if you're doing it correctly. 0 minus 12 is negative 12x cubed. Same thing, I'm going to go back to my x here. So x times negative 12x squared gives me this negative 12x cubed. Then go and bring down my negative 6x squared. Then I've got to take negative 12x squared times x plus 3 to get this next line down here. So negative 12x squared times x is negative 12x cubed, and negative 12x squared times 3 is negative 36x squared. Let me subtract. The first one cancels. Now negative negative becomes plus, so negative 6 plus 36 is a positive 30x squared. Bring down the 2x. Alright, same thing. X goes into 30x squared. We multiply by 30x. So then for my next line, we have 30x times x plus 3. Alright, so 30x times x is 30x squared. And then 30x times 3 is 90x. Alright, subtract. 2 minus 90 is negative 88. And then bring down the negative 5. And we do it one last time. So x times negative 88 gives me this negative 88x. So then we do negative 88 times x plus 3 to get my last line down here. So negative 88 times x is negative 88x. Alright. And then negative 88 times 3 is negative 264. And then we subtract. First one's cancel. Negative negative becomes a positive. So negative 5 plus 264 is going to give us 259. I have nothing else to bring down, so I have nothing left over. I do have something left over. I have a remainder of 259. So the way we write our answer is whatever's on top of our division bar. So 4x cubed minus 12x squared plus 30x minus 88 plus my remainder of 259 over what I divided by x plus 3. Because I have this remainder, that means that x plus 3 is not a factor of this polynomial that we were dividing. If there was a remainder of 0, then it would be a factor. Alright, synthetic division is similar. Right? It's a little quicker, it's not quite as many steps. But remember, you can only do synthetic division when you have an x to the first power by itself and that you're dividing by. If that was a 2x or an x squared, we wouldn't be able to do synthetic division. Alright, this is the same problem we just did, but it's written a little differently. I have a division bar. This is the same thing as the top divided by the bottom. Alright, so in this case, I'm dividing by x plus 3, so I'm going to put a negative 3 in my box. And then I need to line on my coefficients. But remember, I'm missing that x cubed term, so I've got to put a 0 in a placeholder. So I have 4, 0, negative 6, 2, negative 5. Cut off that last one and make our t and bring down the first term. Alright, remember from the bottom I multiply, then I add straight down. Multiply, add straight down, and so on. So 4 times negative 3 is negative 12. Add, we get negative 12. Negative 12 times negative 3 is 36. Add, we get 30. 30 times negative 3 is negative 90. Add, we get negative 88. And times 3 is negative 264. Sorry, positive 264. And then we add, and we get 259. I started with x to the 4th, so my answer is going to start with x cubed. So 4x cubed minus 12x squared plus 30x minus 88 plus 259 over that x plus 3. That's my remainder. Remember, this is always your remainder, and if that's a 0, then you don't have then it is a factor. If it's not, then it's not a factor. Alright, so real quick to review factoring, GCF you always look for greatest common factor. Alright, start with your smallest number, and it's always your smallest exponent. Okay, difference of squares. If I have x squared minus 4, the square root of x is x, the square root of 4 is 2. So my pattern is just x plus 2 x minus 2. Grouping, you need to have your 4 terms, and then you split it in half. Plain Jane trinomials, you want to multiply to C, add to B, and then trinomials where A is greater than 1, we have bottoms up, or reverse box. And then our cube pattern, let's see, if I said x cubed minus 8, right? I'm going to start with the cube root of x, which is x, or x cubed, which is x, and the cube root of 8, which is 2. Then I have a little parentheses and a big parentheses. So I bring down the x and the 2, square the first one, multiply them together, square the second one. Then remember my signs, we have SOAP. So same sign, opposite, always positive. And that's my cube pattern. All of this is in the foldable that we made in class. All right, graphing polynomials. Okay, we're going to use the calculator to help us out. But a couple of things you need to be able to tell just by looking at your equation. If it's even or odd, that's always talking about whatever when it's in standard form. Right, you always look at your first term. So this is x cubed. Right, so cubed at 3, that's my degree. All right, so this is a third degree, and 3 is odd. So in this case, it's an odd degree function. All right, my leading coefficient is a positive 3. All right, so remember, odd's always going to be opposite ends. So it's either going to be bottom left, top right, or top left, bottom right. All right, so that's if it's positive and negative. So this one's positive, so that means I'm bottom left to top right. All right, so then that means that my end behavior, it's always going to set up this way with x to negative infinity, x to positive, and you all know what y is doing. Well, because this is an odd degree function, these are my end behaviors. So as I go to the left, y is going down, and as I go to the right, y is going up. Domain and range for every odd function is all real numbers. Every single time. All right, the max number of real roots is always whatever your degree is. So in this case, I have 3 roots for my max. And that's real roots. We could have imaginary. And my max number of terms is a degree minus 1. So at most, I will have 2 terms. X and y intercepts. Your y-intercept is always your constant. So in this case, my y-intercept is at 0, negative 5. Your x-intercepts we'll look at on the calculator. Right? You have relative and absolute max and min, which we will also look at on the calculator. So let me pull up my calculator. And so I'm going to go to y equals, and my equation was 3x cubed plus 2x squared minus 5. All right, so here I have one x-intercept, which looks like it's at 1. All right, and I don't have any relative or absolute max or mins because it never goes back down. There's never any terms here. All right, it goes up forever. All right, so no max or min, and my x-intercept is where it crosses the x-axis, and it's right there at 1. All right. And then solving polynomials. We have a couple different ways. Factoring using the quadratic formula, graphing, just finding those x-intercepts, and then division using the zeros. All right, so the division using zeros is talking about finding your zeros, the real zeros on your graph by looking at the graph, and then dividing. So like if I found that my 0 was at 2, 0, I would take this polynomial, use synthetic division to divide by 2, negative 6, and then take whatever equation I have left over and divide it again, or factor it, or whatever I need to do until I get down to all of my zeros. Okay, so I mean by factoring, this is a cube pattern, so it's going to become same, opposite, always positive. All right, so I have one factor here at negative 1, so I know that that's a factor. Now this one I can do the quadratic formula to find my other 2 factors because it's quadratic. So remember the quadratic formula, negative b plus or minus square root, b squared minus 4ac, all over 2a. All right, so again, multiple choice test, you could just solve by finding your x-intercepts. You just have to make sure you look for any imaginary solutions once you find all of your x-intercepts.